Hello everyone, this is a tutorial on how to use the XADC in a Vivado simulation. Let's start by creating a new project. New. Next. In our simulation, we'll be using the Zyble board Z720. Before we begin, I want to set our project to VHDL. So under Project Manager, Settings, switch to VHDL. All right, let's start by creating our XADC using the XADC Wizard. To our left, IP catalogs. Search for XADC. Double click on the XADC Wizard. Options. We have two. We'll be using the dynamic reconfigurable port. We also can use the AXI, but we'll not be using this for our tutorial. We'll select continuous mode, channel sequencer. We'll leave default options for the timing. And for our analog sim options, we want to use a sine wave. We can also choose triangle or square, but for our scenario, let's just create a sine wave with one wave at 1 kilohertz. We'll not be using the reset. Channel averaging will be 16, not relevant to our simulation. Alarms, we'll turn them all off because we'll not be using this for our project. For channel sequencer, we'll be using 6, 7, 14, and 15 for our project. This is what enables your channel, so select as many as you need. Overview, and hit OK. And let's generate our outputs. Let's start by creating our simulation file. Add sources. Add create simulation sources. Let's create a file. I'll be writing in VHDL. We'll call it testbed XADC. Finish. Hit OK. And there we go. And let's start by opening our simulation file, the testbed. And to import our instance of the XADC, let's go IP sources, VHO file, double click. Let's copy in the component. And let's put it right after the entity and the instance file. Goes here. All right, after coding the project a bit, let's see what we have right now. We've declared our system clock period of 10 nanoseconds. This will generate our 100 megahertz system clock. We've added a few signals to catch the signals coming out of the XADC. For example, the data out, the data in, the address select, the channel out of the XADC, data write enable, the DRP enable, and a conversion and a sequence, busy, alarm, and DRP data ready. We all initialize the value to 0 and the V auxiliary to 0. This variable right here is our clock sim. This is what we use to generate a clock within our simulator. These are the components that we copied previously. And this is our instance of the XADC. Notice that we put our data in here. Address select, enable, all the signals that we created previously. Right here, we hook up our data. We want our data or DRP enabled to be ready at the end of a conversion, so we know to pick up a new data from the DRP. For address select, we'll just set it to the current XADC channel that's being converted and concatenate with 2 zeros because our channel select is only 5 bits, but our data address is 7 bits. This right here will generate our clock. It's a simple process. It just flip-flops our SIM signal or SIM clock signal up and down every half system clock period, generating our 100 megahertz wave or our clock. After that, we just wait for 100,000 clock cycles, which is our 1 kilohertz signal. Before we run our simulation, we need to add our design text into our simulation sources. So add a file or add a source. Add create simulation source. Add a file. Go into your FPGA project. So ours was project 1. Go to Gen. Sources, IP, XADC Wizard 0, and switch this to all so you can find the design TXT right here. Finish, and your file will be inside right here, your simulation sources. We're on our simulation. Press OK. Expand it, and we see it's only gone to 1,000 nanoseconds. Yeah, 1,000 nanoseconds. We want to step it out, so I put mine to 5 seconds. Hit play. Go back, expand it, and you'll see this. Let's try zoom it. Actually, let's try set the data out to an analog wave. And right there, we have our 1 kilohertz signal, 1 wave. And we can see all the individual data within our simulations right here. Our busy signals and a conversion as sequence. Our DRP enable signal. Everything's right here. And that concludes my tutorial.